Hello and welcome back to Calculus 3, section 11.6, Calculus of Vector-Valued Functions. So in Calculus 1 we learned that calculus is a study of change, and we learned that calculus consists of three topics: limits, derivatives, and integrals. We learned that limits were that fancy way to find the y value. Derivatives measure the rate of change, and integrals measure the accumulation, the sum, application area under the curve, and else. So now, in terms of vector-valued functions, so if you take any one of these, done on vector-valued functions, what we get, the procedure-wise, is do it term-wise. Lecture is over. We can literally leave because there is nothing else there. Your vector-valued function is a vector that contains three independent separate functions. You take limit of three of those, independent derivatives of three of those, independent integrals plus C1 plus C2 plus C3, or minus 3. So this is technically done. Now we can talk about the necessities of this in terms of the what we're going to do with functions. In terms of, you have a position function. The ant was walking on that line in space, and then what's its velocity? What's its acceleration? Right? Right?
Of course.
Thank you. So we have these three concepts, and as I said, we just work it out term-wise. Now, the largest thing here is just a lot of writing. That's all it is. So let's see if we can find. I'm just going to go into so just to give you, it's like a formula or whatever. So for limits, we have that the limit of r of t, where t goes to some value c, is going to be understood as the limit of f of t as t goes to c, comma, limit of g of t, and the limit of h of t, t goes to c. So as I said, three independent limits. The derivative in respect to t of the vector-valued function is again going to be the derivative of the f dt. I don't need the t because there's dt in the bottom. The g dt dh dt, three separate derivatives, and then the integral of the vector valued function dt is going to be again a vector integral of f of t dt, comma, integral of g of t dt, and integral of h of t dt. So that's what means term-wise. You look at each one of these functions as a separate function, and then, as Nike would say, just do it. We already know that some kind of curve in space, this awesome curve in space, is represented as r of t, which is a path, okay? So that's a path in 3D, and you have a little ant walking on it. So the path is, you say at this point here, let's say t is equal to 5, at this point here t is equal to 7, and so on, seconds, hours, whatever it is. The trick is that at any point in time, when you have the path, its derivative is going to be the velocity, and this is going to be your capital V of t, velocity of t, but that's actually the derivative of r. These are all vectors. And you're also going to have acceleration, a of t, which is also a vector, which is going to be the derivative of velocity vector. And you're going to have that at any single point you can possibly think of. So r of t is given to you. You need to be able to take the limit, take the derivative, take the integral for all of those. So let's pick a value.
Monday's going to be like this, I'm sorry.
That's good.
Just through the end of chapter 11?
No, just this one. That's it. 11.6.
This is 11.6 though. How
Yep.
far does it go?
11.10.
Damn. Okay.
All right. So what we have here is the r prime would be notation for the derivative, right? And the r prime notation is the derivative of the vector r, which you do component-wise. So say vector r of t is given as e to the 3t, negative 1 over t, and 5t squared. What is the r prime of t? Three e to the 3t, what else? Nice. Negative of absolute value of t. Negative ln of absolute value of t. And then what else? 10t. Oh yeah, that's minus 1. It's negative 2. So it's negative 1 over t squared. Yes. The other one is the integral. You're right. Yeah, this is good. What happened? Well, it's okay to be wrong. It's okay to be wrong as long as it's fixed. All right. What else? So say, well, let's do the same. What's the, forget about line. Let's just do the integral of r of t dt. What's that equal to? One third, so e to the 3t over 3, good. Then, now we have negative ln of absolute t. And the last one? Very good. Oh, plus c's. We know that we add vectors x component to x component, right? So if you don't put plus c in Calc 1, that's minus 1 point. What happens when you don't put plus c1, plus c2, plus c3? You still lose 1 point, right? Depreciation in value. So this is indefinite integral. Indefinite integrals have the constants. Now we know that two vectors, right? Two TD vectors are added, x component to x component, y component to y component. So C1 corresponds to the first one, and so on. That should be clear. Right. Now, I think in this section is this huge definition. Ah, yes, there it is. All right. Sense the tone. Unit tangent vector. Unit tangent vector t is vector r divided by, sorry, the derivative of vector r divided by its magnitude. For any dimension. Clearly in Calculus 3 we only worry about 2D and 3D, mainly 3D, but 2D as well. This thing will be all over the place. So this is an extremely important definition. Now, what do we know about tangent lines? How do we get a tangent line? What is the main ingredient in figuring out a tangent line? Yeah, what's the change? What's the word we use? The derivative. So when you are trying to memorize the formula, use some common sense, right? Tangent line, we're talking about unit tangent vector. We're not talking about the tangent from trig. We're talking about the tangent line. Tangent line, we have the derivative. There it is, the derivative. Now, remember the unit, right? How do we find the unit vector? You divide the vector by its magnitude. So Control C, Control V with the magnitude, right? So the word unit has the right form of dividing vector by its own magnitude. And then the derivative is there because we are looking for the tangent, which is related to like tangent line. What is this? This is exactly that velocity that I was talking about. Now, when you scale it down to 1, like if you leave its magnitude, so if you, r prime is the derivative, which gives us the direction, and the bottom part, which is the magnitude of the same vector, is going to scale, right, through division. is going to scale it down to 1. For later purposes of, you will see 5,000 formulas which contain this piece inside. So make sure that you know how to compute this one, like that.
So this is the velocity.
This is not a velocity, this guy is a velocity. Right? This is just the directional velocity for, I don't know, 1 mile per hour. Like that's a unit, 1 mile per hour. So this is more about the direction, this one, because its magnitude is always 1. That's what the unit means, right? Yes. Which we actually don't use. Because you will see every single application, as soon as you start doing next class preps, they'll have vector t, which is a unit tangent vector to describe everything else. I mean, if you need to find velocity, obviously, yeah, that would be. This thing over here is your v, right? Regular v of t that you know, except it's a vector now. And it will have 3 components, and then you, right? Okay, so now here is the example. How about we look at that helix? Why not? For all of you biologists in class. All right. No complaints? Good. So r of t, we'll use the exact one from earlier. So 3 cosine t, 3 sine t, t. Come on, guys. Clearly it's a grind, right? So just grind. Most of Calc3 is grind. Just gotta write it out forever. Find the magnitude, divide into each component. Get that stuff. You hopefully all remember the formula for magnitude, right? Because that's what we need in the denominator. So figure out r prime first, derivative component wise, then the magnitude, then put everything together. time is up for all of these 3 Calc 1 problems and whatever amount of algebra. So R prime would be negative 3 sine t, 3 cosine t, and 1. The magnitude of that vector is the square root of negative 3 sine t squared plus 3 cosine t squared plus 1 squared, which is 9 sine squared t plus 9 cosine squared t plus 1, which is clearly root 10. Clearly?
Right.
Yeah. Because we factor out 9, and you have sine squared plus cosine squared, which is 1. So you have square root of 9 times 1 plus 1, which is root 10, when I said clearly on the first line. So now you have a square root of 10, and your tangent, unit tangent vector, you can put the hat on it because it's a unit vector, is a vector r prime, which we know it's negative 3 sine t, 3 cosine t, and 1 divided by root 10. You can rationalize it, you can leave it. Check what your homework wants you to do, if they rationalized or not. So we have negative 3 over root 10. We should rationalize. And I said it, and I'm still not doing it. Terrible. But there it is. I put on a cloud. In few of the future sections, this would be the first step of your problem. Then you go and you do what you were supposed to do. This unit tangent vector is going to be part of formulas. You really need to know. So cross product, this calculation, figure out the magnitude of the vector. So all of those calculations have to be second nature. So just do 500 problems each, you'll be fine. They say 500? I meant 600. Right. I mean, listed 3 concepts, 500 is not divisible evenly, right? 600 is better. Quarter to 8, really? Like anyone would care anyway. That's how cruel the world is, right? So the unit tangent vector is going to be the vector v for the tangent line to the space curve. Okay? So the parallel concept to the tangent line from Calc 1 is going to be tangent plane. So when you have some kind of a shape and you pick a point, there will be a tangent plane to it. And we learn that later, next chapter. What we are dealing with tonight is a curve in space, and there's going to be a tangent line right here, say, right there. tangent line. Now this tangent line has a direction vector, right? That's this guy. So at each point along this curve, this tangent vector is going to have a different orientation. The tangent vector is going to give you the v for equation of the line, and the point at which you are looking for that tangent vector is that point r0 that you need for your equation of the line. So you can find the 3D equation of the line, which is your tangent line. So let's find a derivative. I'm trying to find if they have anywhere where they say find a tangent thingy. Let's find the tangent line here. I'm going to augment the problem. So I don't know, 28. So they want a unit tangent vector. Which is the t. But I will say find tangent line. So find tangent line. Oh wait, did I start? Whew. For the moment I forgot if I started the stream. So find tangent line for r of t is sine cosine e to the minus t. Okay, so sine t cosine t e to the minus t at t equals 0. So we want to find the tangent line at t equals 0. So we know that the vector v is going to be unit vector t for our line. Which will give us the direction. And then we just use t equals 0 to find r0. How do you find r0, by the way? Plug in 0 into r. Very good. So r0 is r of 0. You plug 0 in there. You plug whatever point is given, right? As the initial point. Cool. So let's go. R prime is what? Very good. Oh, that was fast. That's what I said. So derivative of sine is positive cosine, derivative cosine is negative sine, and then negative e to the negative t. Then we need the magnitude of it, which is all of them squared. The first one clearly goes to 1, right? So we're having a square root of what? We have to square this, so the negative goes away. And what do we get? E to the negative 2t. Good. Now, I'm just going to do some algebra in case this can be made better. So this is 1 plus 1 over e to the 2t. When I add fractions, it's going to be e to the 2t plus 1 over e to the 2t. And I'm going to kick this e to the 2t outside. So I don't know if this is going to help down the line, but I'm just going to have it ready as square root of e to the 2t plus 1 divided by e to the t. Wait, what happened with my minus sign? Why is there no minus? Oh no, I put it down. No, that was good. Okay, so that's it. So what's R0? 0, 1, 1. Yep. Maybe I should, let me write it. Sine of 0, cosine of 0, e to the 0, which is 0, 1, 1. Actually, wait, that's not a vector, that's a point. It's a point. And the vector t, which is our v, is going to be what? Cosine t divided by square root e to the 2t plus 1 over e to the t, comma sine t, negative sine t, square root of e to the 2t plus 1 over e to the t, comma e to the minus negative t divided by square root of e to the 2t plus 1 over e to the t, 2t. So now e to the 2t and e to the t, they go up on top. So we have that the tangent vector, which is our slope v, is e to the t cosine t divided by the square root of e to the 2t plus 1, and then comma negative e to the t sine t divided by the square root of e to the 2t plus 1. And the last one is negative e to the t over the square root. Yes. There's negative over here. You are dividing negative number by positive. Sorry, you're multiplying negative number and positive number. So the answer better be negative. Now we're supposed to compute this at, right, for vector v. We compute this at 0. So we get the first one is 1, 1, 1, so 1. The second one is 0. And the third one is negative 1. On the bottom, we actually have divided by root 2. Right? E to the 0 is 1 plus 1 is 2. So square root of 2. Awesome. There it is. Root 2 over 2 over 2, 0, negative root 2 over 2. And I can find the tangent line. X, Y, Z. We have this form where we are using, what was our point? We calculate 0, 1, 1. Root 2 over 2t. There we go. So the tangent line R Well, we can't call it R anymore. Here, capital R, whatever. And there it is. There's a 1 I missed. So this is the vector valued function. It's a straight line and it's a tangent line to the motion. Yes? To find the actual vector, right? At the point. Because everything is happening at t equal to 0. So all of the calculations are done there. Your derivative calculation is done there. The point is, right? If you think back to linearization problems in Calc 1, you have to compute everything at the point that you were linearizing, right? So you're given a function, I don't know, square root of x, and you're linearizing around 9. Square root of x, so square root of 9 is 3. Right? So you'll be using that value as a y when you're looking for the equation. Ta-da! I have no doves or anything. It's over. That's it. Until the next time. No grand finale. I'm sorry. I just walk out. Yeah, bye, stream.